The ocean. Everything seems to be headed on a one-way trip down to the ocean. Rivers flow down into the ocean. Mountains are worn down by rivers that carry them, piece by piece, down into the ocean. Soil and minerals are carried down into the ocean. And along every coastline in the world, the waves keep chopping away at the land and dragging the broken pieces down into the ocean. Well, is the ocean a bottomless pit that can keep endlessly swallowing the land that pours into it? How deep is it, and how wide? And where does it end? Let's look at the ocean. All you have probably ever seen of the ocean is the top, unless you are a good diver, in which case you may have seen it a few feet under the surface. But the ocean is, of course, much deeper than that. In most places, it is over 2 miles deep. That would seem quite deep if you tried to reach the bottom, but actually, the ocean bottom is only a rather shallow scoop in the huge earth. The scoop is not smooth and level, so there are many underwater hills and valleys. Some of the valleys are as much as 7 miles below the surface of the water, and some of the hills are so high that their tops jut up above the water. Whenever the tops of these mountains reach above the water, there are islands in the vast ocean. The ocean has a bottom and it has a top, but where does it end? Does it end along the coast of Europe or Asia or the North Pole, or where? In what direction would you sail to find the end? You could never find the end because the ocean has no end. It is one big ocean that goes all around the world in every direction. And because the one ocean goes all around the world, it is possible to sail to any harbor. No matter which way you sailed or which land you came to, you could sail around that land into another part of the world. Even though there are many ocean names, the Atlantic, the Pacific, and the Arctic, these are only names that different people gave to that part of the ocean they knew. The one great ocean covers most of the world: Asia, Africa, North America, and all the other big chunks of land, which are called continents and on which the people of the world live, are really large islands in the one big ocean. The ocean, like all other things, keeps changing too. Sometimes the surface is calm, while at other times the waves are high and breakers come smashing against the shore. And you probably already know about another change. You know that the ocean is slowly becoming saltier and more full of minerals as the rivers keep pouring in their loads of salt and other dissolved materials. Down at the bottom of the ocean, another change is going on all the time. The ocean bottom is gradually being filled up. Every minute of the day and night, a steady rain of tiny particles keeps settling softly on the bottom, heaping up layer on top of layer. What are these particles that keep shifting down all the time? They are of several kinds. While rivers drop most of the light particles of sand and soil which they are carrying when they enter the ocean, some of the lightest material still remains afloat and is carried many miles out to sea, settling slowly all the time. But the steady rain of tiny particles that keeps filling up the ocean bottom is mostly a rain of skeletons. Along the surface of the ocean, there live tiny animals and plants, so small that a quart of seawater contains millions of them. These tiny animals and plants are of many different shapes and sizes, but most of them are alike in one way: they have hard, tiny skeletons. These tiny creatures live on the surface of the ocean, but when they die, their soft parts break away and their hard skeletons sink slowly down to the bottom of the sea. Although these skeletons are tiny, they keep dropping down in vast numbers, millions of them every day on each square foot of ocean bottom. And other skeletons keep falling down too. The skeletons of fish and other sea animals that have died or been eaten. This rain of skeletons has been going on for millions of years. so that by now there are parts of the ocean bottom where the layer of skeletons is over 10,000 feet thick. The ocean bottom is also being filled up by another material, the ash from volcanoes. Throughout the world, there are about 400 volcanoes that every once in a while fling huge clouds of fine ash high up into the air. Most of the world's volcanoes are located near the ocean, so that much of that fine ash is thrown into the air and falls into the water. This ash then sinks to the bottom in a soft, steady stream. The piling up never stops. The skeletons, big, little, and tiny, keep heaping up. The volcanoes of the world keep pouring out clouds of fine ash. The rivers keep pouring in tons and tons of sand and soil every second. Bit by bit, the ocean bottom is filling up. When the ocean fills up, well, what will happen as the ocean bottom keeps rising? Will it just flood the beaches and coastlines? Will it matter to people who don't live near the shore? Here's an experiment that will give you some idea of what can happen as the ocean bed continues to fill up. Experiment. You will need a baking dish, sand, enough to fill half of it up, a cup, a sheet of paper, and water. Do this. Pack the sand in a slanting position, as in the picture. Place the sheet of paper against the sand and then slowly pour in water until the dish is about half full. The sheet of paper will keep the sand from being washed into the water. Then carefully slide out the paper. With a crayon, make a mark at the water level on the side of the dish. Now you are ready to do a little world changing. The sand in your baking dish will be the land and the water will be the ocean. First, make some waves by splashing the ocean with your hand. You will see the sand at the shoreline wash away and slide into the water. Along the shorelines of the world, too, the waves are cutting away the land and sliding it into the sea. The material sinks down and adds to the ocean bottom, just as it did at the bottom of the dish. Now, let's do something about rivers in your baking dish. Do this. With your cup, dip up water from the ocean and pour it on the land at its highest peak. You will find that the sand is washed away and is carried out into the water. Here it sinks to the bottom. Try it with a few cupfuls. Now, look at the water level mark that you had made at the beginning of the experiment. You will find that the ocean in your dish is now higher than when you began. You have the same amount of water as when you began, but the level is now higher. In the same way, when the ocean bottom heaps up with dropped material, it makes the ocean rise too, even though the amount of water remains about the same. Now, look at your land. You will find that the land is less steep than when you began, and there is less land showing above the water. Even though you have the same amount of sand as when you began, most of it is now underwater. The same things that happen in the baking dish are happening in the real world. Rivers are cutting at the highest parts of the land and carrying them down. Ocean waves are cutting and hammering away at the shorelines. A good part of this land material is being carried out into the ocean and sinking to the bottom. The ocean bottom is being heaped up with all this material and with volcano dust and animal skeletons. As this heaping up continues, the water is lifted higher and flows further over the land so that there is less dry land and more ocean. Will the world drown? What will happen if this keeps on year after year? Will the world someday be mostly ocean with just a few high peaks still sticking out as little islands here and there? Will all the people of the world be left huddling together on the remaining bits of land? You needn't worry about it at all. In the first place, the wearing away of the land is a very, very slow process. It would take millions and millions of years for the land to be worn down to sea level. Secondly, even though the land is being worn down, another process is going on that causes the exact opposite to happen. The land is being built up. Oceans on top of mountains. What is going to build the land up and keep the world from drowning? To find our answer, let's go on a voyage of exploration far away from the ocean. Let's take an imaginary trip to the top of a high mountain. We will need with us a hammer, a chisel, a microscope, and a guide. Our guide is a geologist. That is, a scientist who has studied the Earth's story. When we reach the top of the mountain, let's look at the rocks. At first, there seems nothing special about those rocks except that they seem to be arranged in bands, one on top of the other, like a layer cake. These rocks are rather soft as they rocks go, so we can split them easily with a hammer and chisel. If we keep patiently splitting and looking, we may soon come on some things that definitely don't grow on mountain tops. Inside the layers of rocks, we may find snail shells, oyster shells, and even the imprint of seaweed. If we're lucky, we may even find a fish skeleton. Perhaps, you may say, somebody had a fish picnic up here and didn't clean up afterwards. But the geologist showed us something else. Under his microscope, some of the powdered rock shows grains of sand and similar material. In addition, there are things that look like the things in the picture. These things are the skeletons of tiny plants and animals that live only in the ocean. Under no conditions do they ever live on land. Yet, here are their skeletons, millions of them, in a thimbleful of crushed rock, high up on a mountain 100 miles from the nearest ocean. How did they get there? The riddle. How did the oyster shells, fish skeletons, and grains of sand get on a mountaintop? If we keep exploring on our mountain, we will find some clues. For example, some of the rocks, when we split them open, show very wavy marks. These marks look just like the ripples at the bottom of a muddy shore or a mudflat at low tide. It would seem as if all this material had once been underwater. But how could rippled mud at the bottom of the sea have turned to rippled rock high up on a mountain? The answers were not easy to find. It took many years of study by many scientists all over the world to find a reasonable answer. Our mountain is not very unusual. Geologists found such sea remains on mountains in many parts of the world, and they tried to find out why. Of course, nobody can be absolutely certain about something no one saw happen, but from the clues you have read about and from thousands of other explorations, geologists are now practically certain that they know how the mountaintop was formed long ago at the bottom of the ocean and how it later rose to where it is now. That is what they believe happened. The answer to the riddle. Millions of years ago, in this mountainous place, there were no mountains at all. There was just a huge sea that covered a large part of the United States. Some rivers poured into this sea from higher land, bringing in sand and mud, which settled down slowly to the bottom. Where the current flowed somewhat quickly, it stirred the mud into rippled shapes. In this sea, fish and other sea animals lived, and so did sea plants of all shapes and sizes. When these animals and plants died, they sank to the sea bottom and were covered with the sand and mud that drifted down on top of them. Sediment. All this material that settled to the bottom is called sediment. Year after year, for millions of years, the bottom kept heaping up with sand and mud, and with the remains of the plant and animal life of the sea. After many centuries, the sea bottom was heaped thousands of feet thick with sediment. The heaping up did not go on at a steady rate, however. Sometimes there would be a period of many years of heavy rainfall. The rivers would pour in great quantities of sediment and build up thick layers of the sea bottom. In times of little rainfall, the rivers just trickled in, adding very little material to the sea bottom. In this way, the sea bottom was built up in layers of even thickness, one layer at a time. And as it built up, something kept happening to all this sediment. Sediment under pressure. What happened was that these layers were squeezed slowly and steadily for millions of years by the weight of the water and other layers of material on top of them. The bottom layers, of course, were squeezed the most. If you've ever made snowballs or sandballs, by squeezing the snow or sand very, very tightly into shape, you have an idea of how pressure works. This squeezing was one of the reasons the sand and mud at the bottom of the ocean hardened and stuck together. The sticking together process was helped along by some of the dissolved minerals brought in by the river water. Many soils have minerals in them that act as a kind of cement. The plaster on your walls, for example, comes from a dry powdery mineral in the ground. It changes into a smooth, firm surface material after it is spread on the wall. Clay is another kind of soil that dries into something like stone. It becomes strong enough to be used for cooking pots or dishes. Even when it is used as a water jug, it does not become soft. Cement itself is a fine, soft, powdery thing when you get it in the sack. But when it is mixed with sand, water, and pebbles, it changes into strong, hard concrete, used for building roads, bridges, and houses. In such a way, the dissolved minerals brought in by the river water helped change the sediment. These minerals acted as a kind of cement. Working together for millions of years, the cement-like minerals and the squeezing caused the layers of sediment, sand, shells, skeletons, and mud to harden into layers of rock. And because this rock was formed out of sediment, it is called sedimentary rock. Sedimentary rock. You don't have to go to the mountains to find sedimentary rock that was once at the bottom of the sea. No matter where you live, you can almost certainly find some. Railroad lines and highways are often cut right through sloping land in order to make them as level as possible. In such cut-through places, you can find sedimentary rock in layers. In level country, you can find cut-through places along the banks of rivers or where cellars are being dug for new buildings. If you see rock arranged in layers, then you know it is sedimentary rock and that the land you are standing on was once at the bottom of the sea.